Okay, today we're going to talk about solving differential equations. In general, differential equation is any equation, dy dx, where a rate is related to x over 4y, or a rate is related to quantities. And to solve a differential equation, we cis the problem. We separate, we integrate, and then we solve. So, for example, in this generic differential equation, I would actually cross multiply and get 4y dy equals 2x dx. So I've separated the x's and dx's and y's and dy's. Check. Next, I would integrate. I'd integrate both sides. When you integrate, the integral and the derivative part cancel out. And so on this one, I would get 2y squared plus c equals x squared plus, well, there's two separate constants on there. But in the end, I can always, whenever I'm working on any problem like this, any integration problem, I don't have to put two c's on. I know that they always combine to be the one on the one side. I've integrated right there, and I could solve for y if I wanted to. I could divide by 2, get y squared equals x squared plus c over 2, and then I could square root both sides. Now we get y equals the square root of x plus c over 2. Pretty much with these problems, though, it's enough to, once we get the y part by itself, whether it's got constants on there, we're good to go. So this is a generic differential equation. There are some very, very common types, and we're going to look at, over the next couple of days, a couple of different ones. The main one we're going to look at is when the rate of change of population as time goes by. So the rate of change of population varies directly with population. The rate and the quantity vary directly. And this is a differential equation that we're asked to often solve. Now we can put the specifics in here now, but it's just much easier to solve it generically. The steps are the same every time when a rate is directly proportional to the quantity. And the goal is to separate, integrate, and solve, cis. So what I'm going to do is first I'm going to multiply both sides by dt. And I get dp equals kp dt. The next step I'm going to do is I want to get the p's and the dp's on one side. I'll multiply both sides by 1 over p. Yes, that's the same as dividing by p, but this sets you up with the quantity you're going to want, which is 1 over p dp equals kdt. I now have the p's and dp's on one side, the t's and dt's on the other side. There were no t's, but that's okay. And now I've separated, so now I will integrate. Integrate both sides. I get the ln of the absolute value of p equals kt, because the t appeared because we integrated it, plus c1. I could do a constant on both sides. I don't have to. This step works for just that. I have now integrated, and now I'm going to solve. I'm going to get that p by itself. I'm going to e both sides of the equation. Let's cancel. And what I get is the absolute value of p equals e to the kt plus c1. Now this is just one rule you have to remember. I know that e to the 2 times e to the 3 equals e to the 2 plus 3. So I can convert this statement right here to e to the kt times e to the c1. Now, because e is a constant and c is a constant, this thing I've just circled is also some constant. It's a new constant. So I can rewrite this as the absolute value of p equals c2 e to the kt. I just moved it to the other side so it's in front right there. Now I've got to deal with that absolute value sign. Well, I know the absolute value of p, if the absolute value of p, the stuff on the side over here is not part of the problem, it's just the tools we use to get it. I know if the absolute value of p is equal to 2, then P could be equal to positive 2, or P could be equal to negative 2, because when I put it in, it's going to take that sign away. Well, if this is true, that P is equal to plus or minus 2, I can say the same thing about this problem. P is equal to plus or minus C2 EKT. Well, if C is positive, then it's one constant. If C is negative, then it's another constant. I can just suck these plus and minus signs right into my constant to come up with my final solution of P equals C E K T. This is an exponential equation. Just so you know, this C will be a constant. It will be known as the initial value. It's whatever is happening at time 0. And this K will be my rate. Depending on whether my function is increasing or decreasing, that number will change based on that. So this procedure for solving these out always looks like this. And then we get into specific questions that will give us numbers in order to help us solve for other values. Take a look at that in the next video.